The much-anticipated day we've been waiting for has finally arrived, and the third orbital flight test was launched, ending in an unexpected manner. But what caused the unexpected outcome of the third orbital flight test? And what challenges did they face, and what did they mean for our future space exploration? Let's find out. The day started with the Starbase team conducting final checks on systems and assessing the weather. Initially, there were worries about high wind speeds, but the conditions improved, allowing the launch to proceed as scheduled. Several hours before liftoff, the fueling process began. As the countdown reached T-minus 6 minutes, teams double-checked the weather to ensure favorable conditions. With the green light given, the launch director began loading the propellant. By T-minus 45 minutes, liquid methane and liquid oxygen were being pumped into the Starship and its super-heavy booster, a meticulous process observed closely by engineers and space enthusiasts. As the countdown reached T-minus 10 minutes, final system checks were completed. The launch control team confirmed that all technical and safety requirements were met. Just before ignition, the water deluge system was activated, releasing about 350,000 gallons of water at the base of the Starship. This served a dual purpose: to absorb the intense heat from the rocket's engines and to reduce the acoustic shock that could harm the spacecraft, launch pad, and surrounding area. Flooding the area with water created a barrier and cooling effect, significantly decreasing thermal and acoustic stress. The system's effectiveness became apparent as the Starship rose into the sky. The launch pad and its surroundings remained undamaged. At T-minus 0, the activation of the Raptor engines on the Super Heavy booster generated a whopping 16 million pounds of thrust, lifting the Starship and its booster off the ground. This thrust level is roughly twice that of the Saturn V rocket, historically one of the most powerful rockets ever built for the Apollo moon missions. At T plus 1 minute into the flight, the vehicle reached max Q, the point of maximum aerodynamic pressure. This critical moment tests the spacecraft's design and strength under extreme atmospheric conditions. By T plus 2 minutes and 50 seconds, a crucial event occurred: hot stage separation. This maneuver involved starting the Starship's engines before separation, which simplified the process and improved efficiency. In the initial Starship launch, the traditional stage separation method was used, where the lower stage would shut down before detaching from the upper stage. This old method wasn't as efficient because it briefly halted the rocket's forward momentum, causing a loss of thrust and efficiency during ascent. Hot staging solves this by igniting the engines on the upper stage of the Starship before separating from the lower booster stage, maintaining forward momentum without losing thrust, thus making the launch more efficient. It's similar to keeping your foot on the gas pedal while shifting gears in a car to maintain speed. While not entirely new, as it's been used in Russian rockets, its inclusion in SpaceX's system marked a significant advancement. Implementing this technique required adding special vents and shields to the booster to manage the heat and pressure from the engines firing so close together. After separating, the Super Heavy booster began its controlled descent back to Earth. As it re-entered the atmosphere, its grid fins, crucial for guiding its descent, became active. These fins adjusted the booster's path with precision, directing it toward the intending splashdown zone in the ocean. The goal was a gentle landing in the ocean, a method SpaceX has used in tests to minimize risks to people and infrastructure. Cameras on board provided a live feed of the descent, giving viewers worldwide a close-up view of this technological feat. However, as the booster approached the ocean's surface, the signal was lost, which isn't unusual during re-entries due to intense atmospheric conditions. Despite the signal loss, based on the trajectory and performance up to that point, it's highly likely that the Super Heavy booster successfully splashed down as planned. Meanwhile, the Starship upper stage carried on with its mission, performing extra engine burns to adjust its orbit. The engines were successfully shut down after these adjustments, marking a crucial step in the flight. However, there were moments during the mission when communication with the Starship was briefly lost, though it was quickly restored. Around 45 minutes into the flight, the Starship started its re-entry into Earth's atmosphere. This phase is tough due to the intense heat from atmospheric friction. Surprisingly, onboard cameras kept transmitting images, showing the spacecraft enduring the harsh conditions of re-entry. Eventually, the signal was lost again. There's speculation that the Starship was lost during this phase, which, though disappointing, wasn't entirely unexpected given the complexities and challenges of such a test flight, reminiscent of the explosive outcomes of earlier test flights in 2023. Nonetheless, the progress made up to this point was significant. In this third launch, the FAA played a different, more positive role compared to previous ones. SpaceX had faced delays during the first and second Starship launches due to the FAA's licensing process. For the second test, SpaceX Vice President mentioned that Starship had been ready for its next flight test for over a month, but was delayed by the lengthy review process from multiple agencies. This frustration with the private space industry prompted SpaceX, Blue Origin, and Virgin Galactic to collectively urge the Senate for improvements in the FAA's approach to the space sector. They emphasized the need for a simpler regulatory process and increased funding for the FAA to handle launch licenses and enforce regulations. This push came as the commercial space sector was innovating faster than the regulatory environment could keep up, especially with growing competition from countries like China. Executives from top space companies urged that the FAA needs more resources, at least double its current capacity, to better handle licensing for rocket launches. The FAA's approval of the third Starship mission's launch license on March 13th could be seen as a positive result of these efforts. This decision, following a thorough investigation into the previous flight and considering input from industry leaders, indicates a potential move towards a more supportive and efficient regulatory environment. This shift could benefit future space missions and the commercial spaceflight industry as a whole. As the new FAA rules take effect, they are expected to bring several benefits to the space flight industry. Firstly, streamlining the regulatory process will enable companies like SpaceX to conduct launches more efficiently, reducing delays and allowing for quicker innovation. This means that ambitious projects such as missions to the Moon, Mars, and beyond can progress at a faster pace. Secondly, increased funding for the FAA will enable the agency to expand its capabilities and resources, ensuring that it can keep up with the growing demand for launch licenses and effectively enforce safety regulations. This will enhance overall safety standards within the industry, reassuring both investors and the public. Additionally, a more supportive regulatory environment will encourage collaboration and competition among space companies, driving further advancements in technology and driving down costs. Well, that's all for today's update. If you found it helpful, please subscribe to our channel and hit the like button. Thanks for watching, and see you in the next one.